Flying above the mansions and palm trees of Beverly Hills, Howard Hughes is at the controls of the most expensive aircraft he's ever built, the XF-11. After years of delays and millions of dollars spent, the airplane is finally in the air. But suddenly, it yaws violently to the right. Hughes struggles to stay in control and is losing altitude fast. What happens next will leave the XF-11 a burning wreck scattered across the neighborhood and Hughes fighting for his life. Howard Hughes was born in 1905 in Houston, Texas. 4 years later, in 1909, his father, Howard Hughes Sr., patented the sharp Hughes rock bit, which transformed oil drilling and made the Hughes Tool Company extremely profitable. Hughes's interest in aviation started at a young age. In 1914, during a regatta in Keokuk, Iowa, Howard Hughes Sr. paid for his 9-year-old son to take a ride in a Curtiss Model F flying boat. Some accounts say the plane never left the water and only taxied around the lake, leaving Hughes extremely disappointed. But other sources claim it did take off for a brief flight. Either way, the experience left a deep impression on him. Stepping out of the aircraft, he told his father he planned to become a pilot and someday build airplanes of his own. After inheriting his father's fortune in 1924, Hughes left Houston and moved to Los Angeles to pursue a career in Hollywood. Using his newly acquired wealth, he began producing films, eventually gaining attention with early productions like Everybody's Acting and 2 Arabian Nights. While building his reputation in Hollywood, Hughes's interest in aviation remained, and in 1932 he founded the Hughes Aircraft Company in California as a division of the Hughes Tool Company to design and build aircraft. His first major project was the H-1 Racer, a single-seat monoplane featuring a durallium fuselage and composite wooden wings. It had a retractable landing gear which folded up completely into the wing structure, leaving no protrusion to disturb the airflow. Its wooden wings could be sanded and polished to a much smoother finish than the metal working techniques of 1934 allowed, significantly reducing parasitic drag and increasing its speed. In 1935, despite everyone pleading with him to let someone else fly the highly experimental plane, Hughes piloted the H-1 to a new land plane speed record of 352 miles per hour. In 1937, he set a transcontinental speed record by crossing the United States in just under 7.5 hours. This time flying a reworked version of the H-1 designed for long distance and nicknamed the Winged Bullet. For his record-breaking achievements, Hughes was awarded the Harmon Trophy for the most outstanding feat by a male pilot. The H-1 demonstrated that the Hughes Aircraft Company could produce advanced high-performance designs. Hughes felt the H-1 speed would make it an ideal pursuit plane and tried to sell the design to the US Army Air Corps, but unfortunately they declined, favouring survivability, firepower and mass producibility over just raw speed. A year later, in 1938, Hughes turned his attention to what was widely regarded at the time as aviation's most prestigious challenge, the round-the-world speed record. Piloting a heavily modified Lockheed Model 14 N2 Super Electra, he completed a round-the-world flight in 3 days, 19 hours and 17 minutes. The endeavour had captured the collective imagination of the general public. The scale of the reception following his return to New York on July 14, 1938, was similar to the adulation received by Charles Lindbergh a decade earlier. He was awarded the Collier Trophy for the greatest achievement in aviation in America. In the 1930s, Wright Field near Dayton, Ohio, was the centre of military aviation in the United States. If an aircraft or piece of equipment was used by the US Army Air Corps, it was researched, tested and cleared for purchase at Wright Field. Hughes had watched as other aviation companies were winning lucrative contracts through Wright Field. The likes of Boeing, Lockheed, Douglas and Northrop were all busy producing new aircraft and turning a profit. Meanwhile, despite his record-breaking flights and public acclaim, Hughes Aircraft Company remained a small operation that was being funded almost entirely by the profits from the Hughes Tool Company. Hughes was determined to win a Wright Field contract. After failing to sell the H-1, he submitted a design in response to Circular Proposal X608, which called for a high-altitude twin-engine interceptor. but it was Lockheed's Model 22 design, which would become the twin-boomed P-38 Lightning, that won the contract. Hughes took the loss personally. He became convinced that the engineers at Wright Field disliked him and were deliberately shutting him out. In reality, Lockheed's design was simply a better fit for the needs of the Air Corps. Still, Hughes began referring to the Material Command at Wright Field, the centralised engineering and procurement authority, as the Hate Hughes Club. The origins of the next aircraft developed by Hughes Aircraft Company remain somewhat unclear owing to Hughes's strict secrecy over his designs. Some believe its origins are tied to Hughes's desire to set new speed records. Other sources say it was a response to the outbreak of the Second World War, an attempt to capitalise on the sudden demand for all types of military aircraft. In either case, the project began as a privately funded venture without a specific military contract, and it was designated the D2. Its defining technical characteristic was its construction from Duramold, a lightweight, high-strength composite material that Hughes had acquired the rights to. It was created by laminating wood with phenolic resin, which is then cured under heat and pressure. Duramold could be moulded into complex compound curves, which allowed for the construction of an airframe with an extremely smooth surface. Its slippery airframe and weight advantage would, in theory, allow the D2 to outperform metal aircraft of similar power. As an added advantage, the material was non-strategic, which would become increasingly important as supplies tightened in the run-up to war. He wrote a letter to Wright Field in December 1939 to let them know that his company had a new aircraft in development and that he was certain it would be contracted into production. But he was scarce on the details. He didn't even specifically say what type of aircraft it was. Hughes was notoriously secretive about the project, worried that someone would steal his designs. Shortly after that letter was sent, General Henry Hap Arnold, commander of the United States Army Air Corps, was leading a group of high-ranking officers inspecting aircraft manufacturers throughout Southern California. Curious to see Hughes's new aircraft, they decided to visit his facilities to learn more about the D2. But to their astonishment and great frustration, they were denied entry. The guards were under strict instruction from Hughes himself that no one be allowed in without his express permission. As was usually the case, no one could reach Hughes. General Arnold and his staff were furious. They were, after all, in charge of the air defence of the nation. Hughes's secretive way of operating was doing him no favours. Despite investing millions of dollars into the D2, Hughes Aircraft still didn't have a military contract. This meant he was denied access to the engines and other strategic materials he needed to develop the aircraft. More than ever, he needed the government to buy his new plane. He sent a delegation to speak to the Army Air Corps Head Procurement Officer, Major General Oliver P. Eccles. But Eccles explained that the Air Corps knew so little about the D2 due to the secretive nature of the project that it would be completely impractical for him to make any further decisions about the airplane until he knew what it actually was. Hughes then finally permitted Wright Field engineers to inspect the plane, but they quickly decided it was not suitable for military service. They strongly objected to the use of wood, which they felt was outdated and not robust enough for combat operations. It also lacked important military features, such as armour, and adding these would have made the D2 far too heavy. Hughes made several attempts to reverse the decision, but without success. An internal memo at Wright Field sent on January 26, 1942, made clear its opinion of the Hughes Aircraft Company. It is the opinion of this office that this plant is a hobby of the management, and that the present project now being engineered is a waste of time, and that the facilities, both in engineering personnel and equipment, are not being used to the full advantage in this emergency. The Air Corps should discontinue any further aircraft projects with this organisation. By 1943, the United States Army Air Force, renamed in 1941, was in urgent need of a dedicated photo-reconnaissance aircraft. In the absence of a purpose-built design, modified fighters, such as the F-5, a reconnaissance variant of the P-38 Lightning, were pressed into service. Stripped of defensive armament, these aircraft proved vulnerable to Axis fighters and lacked the internal space needed to carry the latest photographic equipment. The loss of forward bases in China had placed many Japanese strategic targets beyond the reach of existing Allied reconnaissance aircraft. United States Army Air Force planners needed something that could fly further and higher without diverting Boeing B-29 Superfortresses from bombing operations. A purpose-built design had the potential to offer greater range and the ability to operate at speeds and altitudes beyond those achievable by a modified fighter. Colonel Elliott Roosevelt, who had commanded reconnaissance units and was the son of President Franklin D. Roosevelt, was tasked by General Hap Arnold to find a suitable photo reconnaissance aircraft, and quickly. Hughes, who had still not given up on the D-2, saw his opportunity. Keen to impress Roosevelt, he sent John W. Mayer, his head of public relations, to look after the delegation whilst they were in Los Angeles. Mayer gave them guided tours of the Hollywood studios and hosted a series of lavish parties. Hughes himself gave them a private tour of his facilities and took them to see the D-2. Roosevelt and his team were immediately impressed by the slick aerodynamic airframe. With a projected top speed in excess of 400 miles per hour and long-range capability, it was exactly the kind of aircraft they were looking for. Roosevelt sent a memo to General Arnold stating that the Hughes design was the only aircraft capable of meeting future reconnaissance needs. In October 1943, following Roosevelt's enthusiastic reports, Arnold was essentially pressured into signing a letter of intent for 100 aircraft, but on the condition that certain aspects of the design were changed. Most notably, the use of Duramold construction was abandoned in favour of an all-metal airframe. The aircraft was subsequently redesignated the XF-11, but Arnold remained sceptical about the order. At that point, it was the Hughes plane or nothing. So much against my better judgment and against the advice of my staff, I gave instructions to buy the famous XF-11 airplane. Material Command were furious, arguing that Hughes aircraft lacked both the experience and facilities for mass production. On November 11, 1943, the only D-2 prototype in existence was destroyed in a fire at Hughes's Harper's Lake testing facility in the Mojave Desert. The official report stated that a lightning strike had set the hangar on fire. Witnesses said the aircraft burned with such intensity that it was completely consumed in a matter of minutes, leaving behind only the steel engine components and landing gear. Throughout its development, the XF-11 suffered serious managerial problems which caused endless delays. This, along with problems with his famous H-4 flying boat project, resulted in Hughes suffering a mental breakdown. Following a scathing report by Colonel Elliott Roosevelt, who had now grown frustrated with the delays, the order for 100 production aircraft was cancelled. The contract was amended to cover only 2 prototype aircraft for experimental testing and evaluation only. Eventually, in April 1946, the first XF-11 prototype rolled out of the final assembly hangar at the Culver City plant. The XF-11 was huge, significantly larger than the original D-2 design. With a wingspan of 101 feet, it was almost as wide as a B-17. It was powered by 2 massive Pratt & Whitney R4360 Wasp Major 28-cylinder engines, at the time the most powerful piston engine ever produced for flight, with each one producing 3,000 horsepower. To transfer all this power into thrust, the XF-11 used an experimental contra-rotating propeller system. A collaborative engineering effort between Hughes Aircraft Company and Hamilton Standard, it featured 2 sets of propeller blades spinning in opposite directions on a single shaft. This eliminated torque steer and increased aerodynamic efficiency at high altitudes. It had a service ceiling of 42,000 feet and a projected top speed of 450 miles per hour. The XF-11 was operated by a crew of 2 within a pressurized cockpit. The photographic equipment, housed primarily in the nose and center fuselage, was integrated into the pressurized environment to prevent lens fogging and film turning brittle in the cold temperatures found at high altitudes. Before it could take to the air, the XF-11 underwent a series of static ground and taxi tests. These checked basic systems such as engine cooling and ground handling, but they also served as an important test of the complex hydraulic systems that operated the contra-rotating propellers. During engine run-ups and taxi runs, ground crews discovered that the right-hand propeller hub was slowly losing hydraulic fluid. If the pressure dropped too low to keep them in place, the propeller blades could inadvertently be pushed into reverse pitch. They estimated the system could operate for about 90 minutes before needing to be topped off. Since the maiden flight was only planned to be 45 minutes long, the team concluded the leak would not pose a problem. On July 7, 1946, the XF-11 was scheduled for its first flight from Culver City, Hughes' home airfield. The plan was for a short flight around the local area to check basic stability, handling and engine temperatures. Experimental military aircraft were normally first flown at what is now Edwards Air Force Base, located in the Mojave Desert. The vast open desert naturally reduces the risk to people and property in case of an accident, but Hughes had persuaded the Army Air Force to allow him to fly from Culver City instead. Hughes climbed into the cockpit at 5:20 p.m. to begin pre-flight checks. Without consulting Glenn Oudkirk, his chief engineer, Hughes ordered the aircraft filled with an additional 600 gallons of fuel, obviously planning to extend the flight beyond the agreed time. By this time, many of the Hamilton Standard technicians had either already left the airfield for the day or were no longer actively monitoring the aircraft. As a result, the propeller hubs were not topped off immediately before flight. The XF-11 would take off with whatever hydraulic fluid remained from the day's final taxi runs. He lined up the multi-million-dollar prototype and advanced the throttles. The aircraft thundered down the runway and was soon in the air. Breaking standard protocol for the maiden flight of a prototype aircraft, Hughes retracted the landing gear once established in the climb, but the cockpit indicator lights failed to show a positive lock for the right main gear. Hughes reported feeling a thumping vibration and aerodynamic buffeting. Rather than landing back at the airfield, he decided to troubleshoot the problem in flight. He lowered and raised the gear a few times, trying to clear any potential debris or misalignment in the locking hooks. His A-20 chase plane came alongside and radioed that the gear was retracted and the door looked flush, but with a red light in the cockpit, Hughes ignored them. He cycled the gear twice more whilst simultaneously flying side slips and sharp pull-ups, trying to physically knock the heavy landing gear struts into their locking pins. Although the indicator remained red, the vibration and buffeting stopped, and this seemingly convinced Hughes the problem was now solved. But in fact, a much bigger problem was developing. This repeated cycling of the landing gear was drawing hydraulic fluid from the same reservoir that supplied the leaking propeller hub. But for the moment anyway, the XF-11 was flying well. He was impressed by the lack of vibration from the massive engines at high power settings. His radio communications with the Culver City Tower were described as euphoric, reporting it was the best handling ship I've ever flown. But the red light on the right main gear was still on, and he began to notice a slight roughness developing in the right engine. After what was already a much longer flight than was planned, he radioed back to Oudkirk, "I'm coming in." Moments later, the XF-11 yawed hard to the right. Hughes had to apply nearly full left rudder and left aileron to keep the aircraft from rolling into a spin. As he fought for control, he scanned the instruments trying to understand what was happening. He failed to realise that the rear right-hand propeller had gone into reverse pitch, and instead concluded that the engine itself was failing. In an effort to clear it, he advanced both throttles to full power. But this only made the situation worse. The hydraulic fluid in the right-hand propeller hub had fallen below the pressure needed to hold the blades in position. With no counter-pressure, the rear set of blades had been thrown into reverse pitch. The front propeller and the entire left engine continued producing forward thrust, but the reversed blades now acted like a powerful air brake. By adding power, Hughes increased the drag on the right-hand side, further increasing the yaw and making the aircraft even harder to control. Realising that the right engine was causing huge amounts of drag, he tried to feather the right propeller, turning the blades edge onto the wind to stop them from spinning and creating so much drag. As he continued to struggle to get the XF-11 under control, the loss of hydraulic pressure also caused the landing gear to slowly start to drop. This obviously increased the drag even further, making a glide back to the airfield now impossible. Descending fast over a densely populated residential area of Beverly Hills, Hughes decided to try and bring the aircraft down on the golf course of the Los Angeles Country Club. But his rate of descent was too high.
Howard Hughes, famous flyer and sportsman, was dragged out of this wreckage of an experimental plane he was testing. He was seriously injured. After ripping the corner from two homes in Beverly Hills, California, the plane finally plunged into this house. The force of the impact virtually wrecked the building and caused the plane to catch fire. The flyer said that the accident was due to motor failure shortly after his takeoff. He failed to make a crash landing on a golf course. Dennis O'Keefe, film actor, inspects damage done the home of Lieutenant Colonel Myers, chief interpreter at the Nuremberg war trials. America's aviation trailblazers willingly pay the price in man's conquest of the air.
Hughes suffered multiple serious injuries. 15 fractured ribs, resulting in a flail chest. His left lung had collapsed. His heart was physically shoved from its normal position to the right side of his chest. He had extensive internal bleeding, a fractured skull, shattered left collarbone, a broken nose, as well as deep burns to his head and hands. The shattering of the cockpit's plexiglass canopy left him with deep cuts over his face. The building strikes had absorbed a large amount of the kinetic energy of the aircraft, slowing it down before it impacted the ground. Hughes would have otherwise almost certainly been killed. Miraculously, no one else was seriously injured. Hughes was transported via ambulance to the Good Samaritan Hospital in Los Angeles. The medical staff initially believed his injuries to be fatal. He was placed in a specialized heavy-duty oxygen tent, which was his primary life support system for several weeks. Unable to tolerate the pain lying in a standard hospital bed, Hughes and his engineers constructed a 6-section articulating bed powered by 30 electric motors, specifically designed to alleviate the pain of his flailed chest. 6 weeks after the accident, and defying all clinical expectations, he returned to the Culver City plant to continue work. But the accident had left a permanent mark. The massive doses of codeine required to manage the pain of his injuries resulted in a lifelong opioid addiction. On April 5, 1947, Hughes remarkably insisted on piloting the second XF-11 prototype himself to validate the design. The experimental contra-rotating propellers now replaced with conventional 4-bladed Curtiss electric propellers. This time, Hughes stuck to the Air Force's test flight protocols. After a 71-minute flight, he landed back safely, stating to the gathered press and military officials, "It's a good airplane, a very good airplane." Whilst the second XF-11 prototype had overall performed well, it suffered from poor handling at lower speeds. Ultimately, the Air Force judged its competition, the Republic XF-12, a superior aircraft, able to fly higher and faster whilst being much cheaper to produce than the Hughes design. But with the end of the Second World War, the strategic landscape had changed. The beginning of the jet age had rendered both aircraft obsolete, now too slow to evade new Soviet jet interceptors like the MiG-15. To fill the gap in its reconnaissance capability, the Air Force chose the Boeing RB-50 Superfortress, a modified version of the B-50 bomber, which was a direct evolution of the B-29 Superfortress. And by 1948, the Air Force already had thousands of trained B-29 pilots and mechanics, along with a huge stock of spare parts, offering a far cheaper solution while the Air Force transitioned from piston to jet-powered reconnaissance. The XF-11 was an incredibly ambitious design that was held back by chronic mismanagement. Endless delays meant by the time it was ready, the dawn of the jet age had already rendered it obsolete. Despite being an incredibly expensive technological dead end, it is nevertheless a fascinating and beautiful aircraft, marking the end of one era of aviation and the beginning of another. Thank you so much for watching. If you enjoyed the video, please consider liking it and maybe even subscribing, as it would really help me grow the channel.